Hello, listeners, and welcome to our podcast on the captivating world of large-scale, language-free visual representation learning. We've assembled a fantastic panel of 5 experts today. Let's start by introducing each of them and dive right in.
Thanks for having us. I'll kick things off. I'm here wearing a bit of a business leadership hat, focusing on how these cutting-edge vision models translate into real strategic value.
Great to be here. I'm excited to share some deep technical insights, especially about scaling these new self-supervised methods and how that compares to language-based approaches.
Likewise, I'm a technical lead specializing in model architecture and data-driven experimentation. I'm thrilled to discuss the behind-the-scenes of scaling from 1 billion to 7 billion parameters and beyond.
Hi, everyone. I've been working hands-on with these massive vision transformers, so I can't wait to dissect the significance of data composition, text filtering, and model capacity.
Hello all. My background is in multimodal integration, figuring out how purely visual models can effectively align with downstream tasks like question answering, segmentation, and more.
Perfect. Let's set the stage. The key question in the field is, do language-free visual models lag behind because they lack text supervision, or is it simply that we haven't been training them on equally massive datasets? Expert 2, want to start?
Sure, host. Traditionally, clip-like models were the gold standard for bridging vision and language. But a new line of research suggests that if you train purely visual self-supervised models on the same web-scale images as clip, you can match or even exceed clip's performance in visual question-answering tasks.
That's right. We used to assume language was essential for robust OCR or chart interpretation. But ironically, with enough data diversity, especially images containing text, these language-free models learn text-sensitive features on their own.
From a business standpoint, that's huge. Companies often invest heavily in data labeling or text annotation to get more accurate image recognition. But if these self-supervised models can perform well without that overhead, it dramatically reduces costs.
Exactly, and it opens the door for organizations dealing with strictly visual data, like manufacturing lines capturing images of products. No attached captions, but still, the model can be trained at scale to detect defects or anomalies, delivering real ROI.
Not to mention fields like finance, where analyzing complex charts or diagrams in strictly visual form could be revolutionized by OCR-like capabilities that come for free in a large-scale SSL model. I once joked that these models see more spreadsheets than many accountants.
Haha, that's a priceless image. An AI rummaging through spreadsheet after spreadsheet. So let's talk about the technical approach. We have these new families of web SSL models. What's the secret sauce, Expert 3?
Well, it starts with a vision transformer architecture, scaled from around 1 billion to 7 billion parameters. We keep the training objective purely visual, like masked autoencoding or joint embedding, and feed in billions of images from a diverse web source dataset.
Precisely. The trick is also in the data distribution. We found that certain subsets of images, those containing textual elements, for instance, really boost OCR performance. So if you filter images by whether they contain text, you might see a big improvement on tasks like chart question answering. A key takeaway is that large capacity and diverse data lead to emergent behaviors, like text alignment, even though text supervision is absent. It's akin to how a child might learn to read street signs just by looking at them enough times, even without explicit language lessons. It's reminiscent of what Einstein said, imagination is more important than knowledge. We're seeing these models effectively imagine textual cues.
I love that analogy. It suggests that we're only scratching the surface. From a business perspective, the 80-20 rule might apply. 80% of the performance gains come from 20% of the improved data strategy, especially for tasks heavy in text or chart interpretation.
Right, it's that final 20% of sophisticated data curation that can get you big leaps in specialized domains like medical imaging or supply chain analytics. Imagine diagnosing melanoma from images alone, no text labels needed, just massive exposure to varied medical data.
That's an interesting pivot. Let me add a small contrarian view, though. We keep talking about scale as if bigger is always better. But at some point, training costs and carbon footprints become real concerns. Everyone's focused on data or model size scaling, but maybe the real bottleneck is the training recipe itself.
Building on that, I think we also need more efficient fine-tuning strategies. If we're training 7B parameter vision models, we must handle them gracefully in resource-constrained environments. So yes, bigger is better until you have to foot the bill.
Right. The endless arms race for scale has some environmental and financial downsides. Let's shift gears. How do these models effectively handle those complex visual tasks, like charts or OCR, that we always assumed needed text supervision?
Well, it's as if the model learns to correlate shapes of letters and symbols with context. Over billions of samples where text appears in natural settings, it picks up text concepts. Then for chart questions, it recognizes patterns, bars, percentage labels, ticks on axes, like a detective scanning for clues.
And from a strategic angle, that means if a manufacturing firm or retailer wants an advanced analytics tool for real-time product label scanning, maybe for tracking inventory, the model can do it. It's not reading text in the typical sense, but it's gleaning the shape-based context from massive unlabeled exposure.
I saw a pilot project do exactly that. A retail business with warehouses used a pure SSL approach, scaled to billions of images, and drastically cut labeling overhead. They integrated it into a multimodal system for visual question answering about product barcodes and packaging. Performance soared, and costs fell by about 15% year over year.
That's a great real-world example. Another instance is healthcare, where these vision encoders handle radiology scans. Even though they're not text-labeled, the models get so robust that they can detect anomalies or measure dimensional changes. It's like rebuilding an engine while driving the car. It's inherently tricky, but if you do it right, the payoff is immense.
Fascinating. Let's discuss the synergy with large language models. We've seen that frozen language models can still benefit from purely visual features. Any insights on that, Expert 4?
Indeed. There's an alignment metric we often examine. Even though we never explicitly align these SSL features to text, they seem to move closer to the LLM's latent space once the SSL model passes a certain threshold of size and data diversity. Absolutely. And that synergy is how you get powerful multimodal question answering. You freeze the language model, map the visual encoder's output to the textual dimension, and voila, impressive VQA results. That's how we match or surpass clip-like models.
Though to be fair, zero-shot classification is trickier with SSL. Typically, you'd want a text encoder tower if you want to do zero-shot prompts, like a photo of a dog. But for those with advanced pipelines, like instruction-tuned LLMs, it's not such a big deal anymore.
Exactly. If a business specifically wants broad zero-shot classification, they might consider a short LLIT-style adaptation or just hooking into a language model. That's a small strategic trade-off compared to constantly paying for labeled data.
Great points. Now, looking ahead, where does the field go next? Are we going to see 14B parameter vision models, or is there a more refined approach?
We probably will push to even bigger scales, like 14B or 20B parameters, but we'll also refine the pipeline. One approach is training high-resolution models for tasks demanding more detail, like microtext scanning.
Another is data filtering or curation. We saw how focusing on text-containing images can drastically improve OCR performance. I suspect entire sub-industries will revolve around data filtering platforms for visual SSL. That's a potential new business frontier.
Yes, and from a strategic vantage, data composition is becoming a new currency. Like, what specialized slice of images do we have that others don't? Those who harness the right 1% of curated data can gain an edge, especially in highly regulated fields like finance or defense.
Speaking of finance, let's loop back. Imagine a large-scale, purely visual pipeline that's ingested billions of charts. Over time, it learns the myriad ways stock trends, bar charts, and annotated metrics appear. Then you combine that with an LLM for textual reasoning on financial documents. That synergy could be a game changer for predicting market shifts.
Yeah, the combination is powerful, but keep in mind, we need some caution about interpretability. We want to ensure these models aren't just memorizing, but genuinely harnessing robust visual representations. Just because a model can do well on a benchmark doesn't mean it's truly understanding. That's a different can of worms.
So maybe the question is, how do we measure true understanding? That's arguably beyond the scope of today's chat, but I appreciate the philosophical angle, Expert 2. Let's circle back for final thoughts. Any last big insights or heuristics?
I'll offer a heuristic. When in doubt, scale out, but do it mindfully. More data, more parameters, but also more strategic curation. That's how you get robust coverage across tasks like OCR, segmentation, and chart reading.
And from me, don't be afraid of a pure vision pipeline. We always used to say that language was crucial for semantic depth, but we're learning these vision-only pipelines can handle a lot more than we gave them credit for.
Yes, and for business leaders, weigh the total cost of capturing high-quality labeled data versus going label-free at web scale. That cost-benefit analysis might shift your entire AI strategy.
This has been fantastic. We covered model scaling from 1B to 7B parameters, the importance of data composition, strategic business use cases, and the synergy with large language models. And we even tossed in a bit of humor along the way.
I love how you casually refer to rummaging through spreadsheets as humor. But hey, if it works.
Well, Expert 2, I appreciate the comedic perfection of the accountant AI scenario. Thanks to all of you for sharing these insights. To the listeners, if you're exploring massive vision models or pondering your next enterprise strategy, I hope you're as inspired as I am. That wraps up today's discussion. Until next time, goodbye. Well, listeners, we promised you a part 2, so let's keep the conversation rolling. After that amazing summary, I can't help but feel we only scratched the surface of the technical and business angles. Let's dive deeper, starting with a more granular view of how one might implement these large-scale, language-free visual models.
All right, let's get nerdy. One of the biggest technical hurdles is orchestrating multi-node training for billions of parameters. Typically, you need a highly optimized pipeline. Something like fully sharded data parallel can help shard both weights and gradients across GPUs. That way, you avoid memory bottlenecks. But it's not just about splitting the model. You also need efficient data loading. Bottlenecks can show up if your dataset is in random order on a slow file system.
Exactly. Also, when dealing with masked image modeling or joint embedding objectives at scale, you want a robust curriculum strategy. For instance, you can start with smaller image resolutions to speed up early epochs, then ramp up to higher resolutions. This approach is a bit like training wheels on a bike. It stabilizes the learning process before letting it freewheel at full complexity.
Right, and if you're running a joint embedding approach, like a dyno-based method, your momentum encoders or teacher-student setups must be carefully tuned. We often see subtle issues like representation collapse if the momentum updates aren't managed well over billions of samples. A small tweak in the momentum decay can make or break your entire pre-training.
Let me add that if organizations want first-mover advantage, they might buy commercial software that can handle distributed training. But a lot of experts prefer open-source frameworks with custom modifications. After all, there's a certain control you get when you can tweak every knob. It does require a strong engineering team, though.
From a strategic angle, that last point is crucial. Spending on the right software stack can be more cost-effective than hiring an army of specialized engineers. But if you want to own the entire pipeline, it's an investment in both talent and infrastructure. There's no single right answer. Just depends on your corporate goals and how quickly you want to move.
Perfect. Now let's pivot to another topic, advanced data strategies. Everyone mentioned that having more images containing text can significantly boost OCR and chart interpretation, but how do you actually implement that?
One method is to do a rough classification pass on your raw dataset using a smaller filtering model that's been tuned to detect text. It might say, yep, this image looks like a chart or a document, so let's prioritize it. Then you feed that curated subset into a standard SSL pipeline, possibly multiple times, or epochs, to emphasize text-rich images. It's basically curation loops baked into pre-training.
Another subtlety is deciding how heavily you filter. Our research suggests that even a small fraction, like 1% of highly text-focused images, can yield massive performance gains on OCR tasks. But ironically, if you overfilter, you may lose out on the everyday images that help models remain robust for general tasks. It's like balancing your diet. You need the right ratio of vegetables to main courses.
I recall one finance institution that curated around 5% of their data specifically for text-containing receipts, bank statements, and stock charts. Their final system delivered a 25% reduction in manual data entry errors. That's an immediate monetary saving and also a compliance advantage, fewer mistakes in official documents.
That's an awesome example. In a similar vein, a large e-commerce platform used self-supervised web-scale models to recognize brand logos and small textual disclaimers on product images. They didn't realize until late that text filtration was the key. Once they systematically curated text-rich samples, their brand detection accuracy jumped from 84% to over 92%.
Let me jump in with a bit of humor. Sometimes folks assume SSL stands for Surely Supervised Labeling, because ironically, we do end up doing a lot of implicit labeling or filtering behind the scenes. But in fairness, it's still unmanned labeling, just orchestrated carefully.
That's ironically on point. Now, about business ROI. Expert 1, you mentioned cost reductions and compliance. Are there other strategic upsides that you see executives focusing on?
Absolutely. Let's talk agility. With a label-free pipeline, you can pivot faster. For instance, if consumer behavior changes or new product categories emerge, you just gather more images from the web or your internal data streams and keep training. No need to scramble for fresh annotations. This adaptability is a massive strategic advantage, especially in fast-moving markets.
It's like the old Winston Churchill quote, "He who fails to plan is planning to fail." By shifting your planning burden back to the data phase rather than annotation, you remain agile. It also fosters a culture of experimentation. Hey, let's see if adding more overhead drone shots or ephemeral video frames helps the model's spatial reasoning.
And from a purely technical standpoint, each new data source can reveal emergent capabilities. We once added a dataset of dense geographical maps with zero text supervision, yet the model started recognizing topographic lines. That was unexpected and powerful. Emergent behaviors really are the hallmark of large-scale training.
Building on that, emergent behaviors can also mean emergent pitfalls. If your data includes biased imagery or unverified content, the model might learn spurious correlations. So you need robust data governance, especially for enterprise settings where brand reputation is critical.
That's an overlooked dimension, definitely. I see a future wave of specialized data auditing startups to ensure everything's curated responsibly. Because if your model has billions of parameters, you sure don't want it picking up billions of mistakes or biases.
Good call out. Before we wrap part 2, any last big leaps on the horizon for these language-free models?
One direction is bridging real-time streaming with self-supervision. Imagine continuous SSL on incoming video feeds, like an endless feedback loop. Another push is exploring an order of magnitude more parameters, but with carefully selected data. Who knows, maybe we'll soon see 70B parameter image models aligning with 70B parameter language models one-to-one.
Definitely. And I think we'll see more domain-specific expansions, like specialized vision models for healthcare, satellite imagery, or even robotics. The building blocks we have are extremely flexible.
And all that means great opportunities for businesses that move early. If you own a unique data source, you can create a self-supervised moat, if you will. Combine scale with thoughtful curation, and you can leapfrog competitors.
All right, folks. We've covered an amazing range of topics and techniques across these 2 episodes. Everything from data curation strategies distributed computing, and emergent behaviors to real-world ROI gains. But before we sign off, let's share some final highlights, insights, and key innovations that might help our listeners connect all the dots. Who'd like to kick us off?
I can jump in. Over these sessions, we've realized the power in scaling these language-free visual models, once considered second fiddle to language-supervised approaches. The conversation showed that the gap can practically vanish with the right data, the right model capacity, and strategic filtering. That's an enormous revelation for businesses that assumed bigger always means paired with text.
Indeed, I see a key innovation in how we handle data composition. We learned that sometimes filtering down to a very small slice of text-heavy images, just 1.3% in some examples, boosts performance on OCR tasks drastically. It's reminiscent of the 80-20 rule. A tiny fraction of data can deliver an outsized improvement. And guess what? The rest of the data still ensures breadth for your general tasks.
To build on that, it's not just about performance. It's also about emergent understanding. We found that purely self-supervised techniques can harness subtle cues in images, like reading topographic lines or deciphering brand logos, without explicit text labeling. That emergent phenomenon has huge potential for industries that deal with specialized imagery, from medical scans to industrial schematics.
Right, and the puzzle is ensuring that scaling doesn't become chaotic. You don't want your model to end up like a giant blueprint with half the instructions missing. With the right distributed training strategy, like carefully tuned momentum or multi-stage resolution approaches, you can keep the learning stable, even when you're throwing billions of parameters at it.
And we shouldn't forget the business vantage point. By skipping extensive labeling, companies can reallocate resources toward, for example, more compute or targeted data audits. The payoff, agility, ROI, and faster iteration cycles has ripple effects across everything from compliance to brand presence. I mean, we heard about that 25% reduction in data entry errors and a 92% brand detection claim. Those are real financial gains.
Absolutely. That synergy between technical brilliance and business impact is what excites me most. I love the part where we discovered that visual SSL models actually act like secret readers. They pick up text and chart details just by encountering enough examples. It feels a bit magical, doesn't it?
Magical and a bit humbling, because it also reminds us that data curation is everything. If you feed the model junk, it'll learn junk. But if you're strategic, you tap into emergent strengths. It's like solving an origami puzzle. Every fold matters, and the final shape can be something truly elegant.
I see your origami puzzle and raise you a famous line from a certain inventor. Genius is 1% inspiration, 99% perspiration. Here, that perspiration is the hours spent ensuring data pipelines, distributed computing, and filtering logic are all done meticulously. Doing so unleashes the actual genius of the model.
Ha! And to add a small dose of humor, sometimes it feels like a 0.1% inspiration and 99.9% debugging. But that's the nature of these massive pipelines. The result, though, is nothing short of revolutionary. We're rewriting assumptions about what's possible with purely vision-based self-supervision. On the contrarian side, I'll say that while we're praising scale, we have to watch out for carbon footprints and resource costs. Even if the ROI is high, the bar for energy consumption keeps climbing. I suspect we'll soon see more research into energy-efficient training paradigms, maybe smaller networks that retain big network capabilities through clever distillation.
Definitely. Another angle is ethical data stewardship. If we're ingesting billions of uncurated images, we must ensure we're respecting privacy, usage rights, and bias concerns. But as we keep saying, the reward for doing it responsibly is enormous. Multimodal, domain-specific expansions that become unstoppable engines of innovation.
Well said. Let's wrap it up with one final statement from each of you. Maybe your top takeaway for leaders and technologists listening in. Expert 1?
Leaders, don't be scared off by the complexity of language-free training. If you invest in the right pipeline and curation strategies, you can outpace those relying solely on text-labeled data. Big potential payoff.
For technologists, be mindful of how you distribute the load. FSDP, multi-stage data resolution, you name it. Scale is powerful, but you must master the tooling to tame it.
You want emergent behaviors? Give your model a feast of diverse data. And if you want it to read text, filter in the right slices. This synergy is your best bet for big breakthroughs.
Keep an eye on sustainability and ethics. Scaling can overshadow these conversations, but long-term success demands you address them early.
And expert 5?
Realize that new capabilities will keep surfacing in purely visual models. Embrace them, see how they fit into your strategic roadmap, and you might just leapfrog your competition.
Perfect. I think that does it. Huge thanks to all our experts for sharing their insights, experiences, and a bit of humor. And of course, thanks to all of you tuning in. We hope this 2-part deep dive has lit a spark, whether you're a CEO pondering your next big move or a developer curious about the future of self-supervised vision. Thanks again, everyone, for listening, and we'll see you next time.